You're watching Cybersecurity Inside, a videocast where you can discover what you need to know about cybersecurity. Here are your hosts, Tom Garrison and Camille Morehart.
Our guest today is Mike Nordquist. Mike is the VP and GM of Commercial Client Planning and Architecture. He has overall product planning and architecture responsibility for Intel's business client platforms, including Intel vPro brand, across both desktop and mobile platforms. So welcome to the podcast, Mike.
Thanks, Tom. Awesome to be here.
You know, we've talked about having you on this podcast for so long, and now it's finally here. And why don't we first just start, Mike, with maybe for those that are listening to the podcast now, just a little bit about your background. I mentioned, obviously, in the introduction that you do product planning and architecture. What does that mean? What kind of things do you do in order to know what to build into the latest products?
Yeah, well, it really starts with the end customers and talking to CIOs, talking to CISOs in this space about what their pain points are. What are their challenges? What are the things they're trying to overcome in this space? And then trying to figure out, hey, does Intel have something they can do to help that? Right? Can we make security better? Can we make manageability better in this space? What types of tweaks can we make into our products? And we have to really get going on that early, because in a lot of cases, it could take us 4 or 5 years to build some specific hardware hooks into our platforms. And so we got to think about that early on. We've got to do a lot of research in that space to try to figure out what those are. And then we take that information. We also work with a lot of partners, right? So we're trying to figure out whether it's, Microsoft or Google on the OSV side of the house, or some OEMs like Dell or HP and Lenovo. Hey, how do we work together with them to try to actually solve those problems that customers have?
How often do you feel like trends in security emerge along a path that's somewhat predictable? Like, it's evolutionary, and you figure, okay, the next thing that everybody's going to need is obviously going to be C because we saw B before that and we started with A. Or how often is it that you and maybe the customer too, I don't know, are completely surprised? Like, there's some use case that people end up applying that no one thought of, and all of a sudden the whole industry kind of has to revamp the underlying security architecture.
There's just a mix of that. There's some things that you plan out. How am I, improving encryption over time in this space? How do I stay ahead of what level of encryption that I need? How do I do things around BIOS and firmware protection in this space? But then there's things that will just get thrown out there that you don't anticipate, you don't see coming. And I think a lot of how you see people attack, you see kind of new variants kind of coming in. And so just trying to solve a problem, especially if you're 3 or 4 years out, saying you're going to address everything, is probably a little bit naive, right? So you have to look at it and say, how do I offer flexibility in this space? How do I do things like looking at behavior versus just looking at a signature of something in that space, and leave some kind of programmability or adaptability in whatever you're designing in that space?
Yeah, well, one of the things that I know we talked about while we were preparing for today's podcast was the sort of evolution of how the technologies evolve, both on the hardware side. How do you make encryption faster or better? And then also on the software side, within the security world, security software has evolved significantly over the years, and how those two sort of come together. And I think one of those areas, obviously, that we wanted to talk about today is threat detection. And I wonder if you could just spend a minute and sort of talk about those two trends, and then how do they come together with threat detection?
For sure, in the space, there's a lot of work that we do just down at the hardware level of securing boot and doing things with the OS. That's great in that space. But there's a whole nother security ecosystem that when you go talk to a CISO or a IT decision maker, a lot of times you say, what's your security strategy? And they'll immediately jump to a software vendor, right? An AV provider, if that's kind of been their strategy, and they start with a software only solution. And 4 or 5 years ago, that's kind of where it was. Like, hey, I'm looking at a software provider in this space. But as we've looked at some of the challenges, just doing software alone was not having the success that they probably wanted. So it was, hey, what could you do next? What are the things that we could do to actually potentially help in that area from a hardware perspective? And so we took a look at that and said, what are the things that we can do? And we started with just small chunks of, we're not trying to boil the ocean. Intel's not trying to go in and replace anything. It's how can we make those products better in this space? And we started with just a basic thing that was around memory scanning. And memory scanning was something that a lot of the AP providers had capability to do, but they didn't do it because it had a performance impact. They would turn on memory scanning to try to look at some of the memory and see if anything was going on there. And then they'd get complaints from their end users. It would say, man, my computer, for whatever reason, it's really lagging. It kind of feels slow. Did something happen? And so it was generating calls. And so as a result, a lot of those AV vendors just turned it off, right? We looked at that and said, you know what? That would be a great capability that instead of just running on the CPU, we could actually go and move it into our GPU that's sitting there, right? It's maybe not as heavily utilized, especially in the business workspace. Let's go ahead and run the memory scanning over there, and that will have a very minimal impact on a highly parallelized, XPU, like a graphics engine, and we can actually go ratchet that up so you get better security without impacting that user experience. And that was kind of our first foray that we did a couple years ago into threat detection.
And you've used a few acronyms that I just want to make sure the audience can understand. So you've said PMU. So let's just quickly go through those. So PMU is?
It's a performance monitoring unit.
Okay. So that's just basically a way for the CPU to be able to track its performance. Then you used obviously CPU. People know what that is. If they're listening to this podcast, they certainly know what a CPU is. But you also used XPU and GPU. Can you tell us what those are?
Yeah, so GPU is just graphics processing unit, right? So it's just your graphics engine that you have integrated into most modern chips that you see today that's in the SoC itself. And then you'll hear us start to talk about, we in general, like at Intel, we can't help it. We love acronyms. Like, I don't even know that I'm saying them half the time, Tom, right, as I'm spitting them out my mouth. But XPU is just, X is just supposed to be generic, right? It's just saying we can bring in other accelerators. And so as we look to our future roadmap, and if you go to some of our architecture days and things like that, you'll hear us talk about VPUs or NPUs, which are just those artificial intelligent engines that were designed more for AI in that space. And so as we kind of look forward into, hey, Intel, that's great. Of course, you always ran stuff in your CPU. Okay, what you just told me now is with TDT, you can now run it on your GPU. So you have a choice depending on what's going to run better. And as we look to the future, you'll hear us talk about XPU that says, hey, if I bring in an AI accelerator that's actually on that platform, a processing unit that's specific for AI, I can run it on that as well. And what we want to do is we want to kind of hide that even from the software. We just want to go ahead and be the arbitrator, and they're saying, where is it going to run best? Where am I going to get the most performance with the least user experience possible, and actually run that? And then they don't have to do anything special. They just write to one layer and they can take advantage of it. And we'll work behind the scenes to decide what's the optimal engine to run this particular thing in.
Mike, is there a specific kind of threat that threat detection technology is looking for, or is it just looking for anomalies for somebody else to investigate if that could be a problem or a vulnerability?
Yeah, well, it's the cool thing about it is it's really programmable in this space. And so when we started it out, we were just doing that memory scanning kind of capability. Then we did some PMU basic stuff that was just helping a little bit on behavioral. Then we moved into cryptojacking, and we did a detector specifically for cryptojacking. And recently we went and we did some of the ransomware capability. And then we have anomaly behavior detection that's coming as well. And so we're building more detectors to look at specific areas. And it just depends on how we want to train those different detectors that we have in this space. And we're building in more capability to support more detectors so you can start mixing those things together as we move forward on our newer platforms.
And do you've mentioned too also just the idea of the detector itself. So how does AI play into this, or machine learning play into our ability to come up with these detectors?
There's a couple different databases that you can actually use to look at a lot of the different malware that's out there in the marketplace right now. And so there's national and kind of world malware databases that you can get samples to. And then we can actually take that information in And we can actually train our detectors to look for those different signatures, to look at the different behaviors. And in a lot of cases, they'll take malware encoder chunks of it out of that, and then they'll write some new malware, but there'll still be some traces of it in there. And so what we do is we actually train it for those various things, and then we're actually able to deploy it through those AV vendors that are out in the marketplace, and actually have use machine learning with TDT actually on those systems to be running real time at that endpoint and actually detect these things as they come through. And then we can actually update them over time as well. So it's not a static thing that you set it once and forget it. You can actually update the machine learning on those end units. And then as we go over time, we actually move into more AI, which actually gets really automated in that space. It's not just machine learning. It is how do we get the thing to think for itself and advance on itself at that endpoint. And that's where we really think the future of this is going.
I'd like to hear more about that. I think what you just said is that threat detection technology is using AI to protect workloads that are occurring. And I'm wondering if you see a future trend to actually protecting AI and how you see that evolving.
We actually have some technology that's coming in the future that will actually help us protect those AI models, right? So if you want to put it on a virtual container, for instance, in this space, you want to make sure that's encrypted, that's protected, because that might be your IP in this space that you don't want shared. There's technologies that we're working on that will actually protect it in this space. I think what we're talking about here, though, is not necessarily that. It's just using the power of machine learning and then AI to actually just see some weird behavior or things that might be happening in your system that shouldn't be happening, right? We want to raise a flag and say, hey, that's a huge problem. Let's go do something about it. So it's getting more information into whatever AV or EDR or XDR vendor that you have to just detect that earlier, right? There's some stats that are out there that we just showed that said, hey, once an attack actually hits, on average, it takes like an hour and a half to move to the second machine, right? So if you're, take a day, you take 2 days, this could get into your system and infect a bunch of systems around you really quick. So you're always looking for that edge that says, hey, if the system has been attacked, how does it notify me as soon as possible so I can take some action on it, so I can quarantine that system so it doesn't move somewhere else, so it's not actually encrypting all my drive. And so really that's what TDT does right now, is it's just trying to move up to that day zero, hour zero, minute zero, as close as we can. Give that edge so I detect it actually right away in that space, and I can decide what to do next. We're not trying to do it on our own. We're trying to integrate it into systems that people already have with ISVs that they already have that just make it more effective and it runs on those Intel systems.
Before we let you go, we have a segment on every podcast that we like to end with called Fun Facts. And I know that you've got one planned for us, and I'm dying to see it. So, Mike, take it away.
So in Oregon, we have Willamette Valley that's not too far from us. They're really known for Pinot Noirs in this space. So much so that Rydell, who's a glass manufacturer, had a special glass, right? That's got this special lip on the top that's an Oregon Pinot glass. And you're like, hey, this is great. And a lot of times if you would go there, they would give you, as part of your tasting on special events, they would give you a logoed glass with this Oregon Pinot glass. And you think it's great. Well, it's got this open air, it really allows the wine to breathe and all, you can get into all the specifics on that. That wasn't what was cool to me. The cool part to me was I was sitting there one time and, one of the people that was working the wine counter was like, that will, potentially, will hold a whole bottle of wine. And he's trying to get me to bet him. And I don't even remember if I bet him at some time, because I think it was probably into my third tasting of the day, but I was adamant there's no possible way, because I was looking right at this thing. And so I thought, just to kind of give a example here, I brought a bottle of wine. It's Eras, so it's one of the wineries that's in the Willamette Valley. And if you actually just go ahead and pour this in, I hope I don't spill all over my keyboard, because that would be really bad. You can see it goes all the way to the top. So,
Wow.
if you have people questioning you, gosh, don't you think you're maybe drinking too much wine? You can just say, I don't have a glass, right? I just have
There you
one
go.
glass, right?
It's a cool fun fact, though,
Maybe a
because
whole bottle, but
optically,
that's the beauty of that glass. You can now get away with that. Like, I never have more than one glass of wine a night. Now, might be cold, but just one glass.
Very cool. Good job, Mike. All right, Camille,
All right.
what's your fun fact for today?
Okay, so the Atlas moth, when it emerges from the chrysalis, and I think it's one of the biggest moths by wingspan, 27 centimeters across or something. But when it emerges from the chrysalis, it has no mouth. So it only lives for about 5 days, long enough to procreate, and then it dies.
Dang. That's weird. No mouth. Wow. All right, so mine is different. This is courtesy of my son, Zach. It is physically impossible to exceed the 70-pound domestic weight limit for a small flat rate box from the Postal Service. So the dimensions, when you do the calculations, the interior dimensions are 75 1/3 cubic inches inside a small flat rate box. If you filled that box with pure osmium, which I'd never even heard of before, but the osmium is actually the densest substance known to man, it would weigh 61.48 pounds. So there you go. So Mike, hey, thanks so much for joining us today. I know we wanted to have you on the podcast for some time. I'm sure there's going to be other topics in the future, given your role, that we're going to want you to come in as well. But you've been a great guest, and thanks for joining us.
Awesome. Thanks so much.
Thanks for joining us for Cybersecurity Inside. You can follow us here on YouTube or wherever you get your audio podcasts.
The views and opinions expressed are those of the guests and author and do not necessarily reflect the official policy or position of Intel Corporation.